So let's take a look at this part. We have an undercut to be mindful of and machining on both sides. We always begin with the stock. The length and diameter are slightly oversized for rough material. Let's begin with the basics, our turning operations. For this operation, we'll use skip groove and back. By doing so, you need to establish boundaries rather than use our feature recognition. I'm also going to use screen pick to estimate my boundaries. This will allow you to click a little faster. The rough leaves material, so I will add a profile operation for finish. We'll skip the backside here as well and change the tool number. I won't go as far to the left to avoid feeding into heavy material. Now for our 60-degree threading operation. I will use a larger start clear value, starting our threading further off the face of the part. The lead-in depth will be set to 0 for auto calculation. However, the latest version, this won't be necessary. As you can see, the lead and the depth have been populated with the correct values. To clear the simulation, just double-click anywhere in the EasyCam window. Turning is in line with the world coordinate system, but our milling is on the side. So let's change the coordinates to side for milling operations. For this operation, we will face both sides to remove the heavy material. The surface and depth are automatically calculated for us. We'll leave them both at 0. Side left and side right determine whether we are machining using the main or sub spindle. We will set the MCS ID to match the active coordinate system we will use for milling operations. Be sure to set a cut step, and to trigger the y-axis is just a checkbox. We don't need to create a new coordinate system for the bottom face. We'll use the copy feature in the existing work step. Select the face of the part to establish boundaries. As you can see, both sides are taken care of. Now we will machine the large pocket. We'll use high-speed machining and use the same location and coordinate system. And with that, we will want to include a finish path. For pockets that bottom out, select the bottom face. As you can see here, we are taking too much material at once when reaching full depth. Let's go in and add a Z-step to machine in layers. Looks great. We have that inner groove to work on. It's a little tricky, but we'll manage. The contour operation is all that is needed for this undercut. Under Advanced Tool, we have the tool parameters to set. The length and cut length will be the same to define our cutter thickness. Let's go over the Z-surf and depth with a minor calculation. First, let's click the top of the groove to extract the surface start point and subtract the thickness of the cutter. And we'll measure the width to help determine the depth. A lead in and lead out are essential. Select the vertical wall to establish our cutting boundary. A tapered surface uses a contour operation as well. Let's verify the surface's taper angle to make certain it is 60 degrees. Notice the operation window can remain open as we do this. The bottom right displays our angle. Don't forget to set the tool's taper angle. From here, we're going to follow the same steps as in previous operations. Based on our surface selection, EasyCam automatically adds the draft angle. Machining the flip side requires adding a coordinate system that is in alignment with the next set of milling operations. Choose geometry and select the vertical wall of our new pocket. EasyCam snaps the UCS in the proper orientation. Switch to a top view. I'm going to check the chamfer angle to be safe. 60 degrees? Perfect. I'll start us off with the chamfer. From here on out, it's pretty redundant. Make sure your MCS ID equals bottom, which we just created. For the last milling operation, we will choose high-speed machining. This pocket does not have a bottom surface, so select the vertical wall. The tool will go beyond the bottom boundary to make sure all the material is removed. The chamfer was produced before our pocket, so select that operation and use the left key on your keyboard to move it up one. Now we are done machining in the main spindle. Let's add a cutoff and get going with the sub, or manual rotation. For this, we'll switch back to the world coordinates. The cutoff is found under the Automation menu. Just a few things here: rapid height, Z location, and the part diameter. Keep in mind, we want to be aware of the rough stock. Go to Advanced and provide all the details for the cutoff tool. Now select the subspindle coordinate system in the list box. Click the top view to verify. We'll take multiple passes using a profile operation. Rough turn would also work. But in this example, we have too much stock for one pass. Set the depth of cut first, then the total stock will appear, which we'll set to 0.75. We have reached the end. Happy programming!